Hello, it's Dr. Harrington again. This is Lecture 6, page 4. Now, as we saw in the last slide, we had to actually do this big process called completing the square. It's actually a lot easier if we don't complete the square and we use a formula for that. Now, the formula comes from completing the square. In fact, what the first piece is if I start off with ax squared plus bx plus c, I get negative b over 2a as the first term here. And you say, well, where does that come from? That actually comes from completing the square. Remember, I had to divide by 2 squared, and it factored out nicely. And then, of course, the y value is f of negative b over 2a. Now, you may have seen a proof for this in your pre-calc class, but it's actually like 2 lines if we use calculus. So we'll actually revisit this in calculus and see that it's really actually trivial to see where these formulas are coming from. Now, all you really have to know is what happens to the a, the leading coefficient, to determine if it opens up or down. So let's actually, and again, you can graph things and do all kinds of things with this. So let's actually do an example. So here I want to sketch the graph of y is equal to 2x squared plus 5x minus 3. All right, now, first thing what you'll notice is one is that it, of course, opens up because of the 3. All right, so that's what so before I even do the problem, I can see what the shape of it looks like since it opens up. So again, it opens up just by looking at the 2 here. Okay, second thing I'm going to do is just find the vertex. So the vertex, let's see if that's easy enough to do. The vertex is, of course, going to be x is equal to negative b over 2a. Now let me label everything. This 2 is my a, this 5 is my b, and we don't really use this in this formula, but we'll use it later on. So I'll just name them right now, give them a good little name. The negative 3 is actually c, obviously. So here I get x is equal to negative b over 2a, so I'm going to get negative 5 divided by 2 times 2, which is going to be equal to negative 5/4. Now, fractions are fine and dandy. You can leave this as your answer, but this is hard to graph, so I usually have to convert this over to decimals. So just as decimals, this is negative 1 plus 1/4, or sorry, negative 1 minus 1/4. So this is actually going to be equal to negative 1.25. And I only write it this way because it's easier to graph. Now to find the actual y value, my y value here is going to be y is equal to, everywhere I see an x, I replace it with negative 5/4. So I'm going to go 2 times negative 5/4 quantity squared plus 5 times negative 5/4 minus 3. Okay, that's pretty much it. And I've just got to simplify and clean this guy up. So I'm going to have 2 times, let's see, 5 times 5 is 25 divided by 16. So that's 25 divided by 16. Oh, and the 2 and the 16 kind of reduce. So that's going to be minus. Then we have 25 over 4 minus 3. Okay. And in the next line, I'm going to have, let's see, 25 over 8. Just rewrite that as 25 over 8. And then I'm going to have minus 25 over 4 minus 3. These are ugly looking fractions, so I'll just go ahead and make everything with the same common denominator. So if I multiply the top and the bottom here by 2, I get 25 over 8 minus 50 over 8, and then here I need an 8, so that's going to be minus 24 over 8, and let's see if I can clean this. That's going to turn into 25 there, and then that's, so I have negative 25 minus 24, that's going to be 49. Negative 49 over 8. Now again, this was what you would leave on the test or anything like that, but because I want to graph it, I'm going to have to rewrite this in a different way just so I can see it. I'll write it as a mixed fraction first. It's negative 6 and an 1/8. Right? You can also rewrite this just so I can graph it because it's negative 6 and 8. Remember, an 1/8 is 0.125, so that's negative 6.125. Okay, because that's what an 1/8 is. Now, to find the x-intercepts, let's go ahead and just set this equal to 0. So I say 0 is equal to 2x squared plus 5x minus 3. And then I'll go ahead and factor this little guy. So I'm going to have 2x minus 1 times x plus 3. Of course, that just equals 0. So I have x is equal to 1/2. And x is equal to 3, negative 3. Ooh. Careful. Now my y-intercept, what I'll do is just plug in 0 for x and see what the y value is. So then y is equal to 0 plus 0 minus 3. The y-intercept is usually the easiest thing to possibly do. So that's just negative 3. Another thing too is you can just look at it. The actual c value, that's the y-intercept. Okay, let's plot this thing. Okay, so what I'm going to do is, I have x is to a half. I get a 0, so it's like halfway there. Negative 3, 1, 2, 3. I put this down here. And then my y-intercept is negative 3. So I go 1, 2, 3. So that's my y-intercept. Now, what you'll notice is that the vertex is actually in between the two roots. So I'm going to go negative 1.5. So that's 1.5. No, not 1.5. 1.25. So there's a half. So it's about half of that. And then I'm going to go down 6.25. So 1, 2, 3, 4, 5, 6. 6 and a smidgen. And 1 and a smidgen here. And so now that I connect the dots, again, this is my vertex. I'm going to have negative 1.25. Again, I usually put them in decimals just to make it easier to graph. You can leave them as fractions if you want. And this is going to come up here. I feel like I'm painting a masterpiece, but just drawing a polynomial. And it comes up there. And so that's my y value, or my actual function, y, which is 2x squared plus 5x minus 3.